So today we're going over 5.2, just the parts that we didn't quite cover in class on Friday. All right, so on Friday I gave you 3 different vocab words that I want you to know and understand. We have a quiz 1 week from today, next Monday, and you're going to need to know these things. So if I were to ask you, what is a ratio or a comparison of 2 quantities using different units called, what would you tell me?
Rate.
It's a rate, okay? If I were to ask you, what compares a quantity to 1 unit of another quantity, what's that?
Unit rate.
A unit rate. So the main thing I want you to know and understand from that is it has a denominator of what? 1, the number 1. So you can see right here, 1 hour, that's a unit rate because it has a 1 in the denominator. And then we talked a lot about equivalent rates. Tell me what you know about equivalent rates. They have the same unit rate, okay? So we're going to go ahead and keep talking through some things that we talked about last week. Before we do, I want to see if you can remind me how to write ratios. Let's say that I have 5 calories to every 3 servings. All right, how can I write that as a ratio? Javaria, what's one way? 5/3. Okay, 5/3. What's another way that I could write that? Nehemiah?
5/2/3.
5/2/3. And what's the final way, class? 5:3. Okay, so the main way that we are going to be using that in our class is we use the fraction bar, okay? Because that helps us to understand the operation that we need to be doing. All right, so we're going to start at the 3rd section of our notes from Friday where it says to find the unit rate. As you can see, we've got $1.32 for 12 ounces. When I want to find the unit rate, what does my denominator need to be? What number?
12.
The number 1, okay? So our goal is to figure this out in 1 per 1 ounce, all right? Does anyone remember how I could do something like this? What do you think?
Is it 1.32, and then the denominator is 12?
You are correct. So the main thing you really want to make sure, OZ is for ounces. You want to make sure that units are attached. What units are attached in my numerator, class? In my numerator.
$sign.
Dollar sign, okay? So dollars is in the numerator. What units are in the bottom?
Ounces.
Ounces, okay? So my goal is to figure out how much it's going to cost me per ounce, per 1 ounce. So whenever you see this fraction bar, what does that mean, class? Divide. I want you guys to put that in your calculator. $1.32 divided by 12. All right, who can help me? What answer did you get? What'd you get?
I got 11 cents.
Okay, he says he got 11 cents. Now, does that make sense for what we're looking for?
Over 1.
Over 1. How did you get that was over 1?
Because you divide by 12.
All right, so listen, if you really want to know and understand, we did just take this and we divided it and we got that. But here's basically what you're doing for unit rate. You are dividing by 12 ounces on both top and bottom, okay? Technically, this right here, 12 over 12, what does that reduce to? What is it, guys? A 1, okay? If I'm dividing by 1, I'm dividing by myself, which means these 2 answers we're getting, they are equivalent ratios, okay? So here you can see I have 11 cents per what? Per 1 ounce. And now you can see that you did find the unit rate because you want your denominator to be a 1. All right, I want you guys to go ahead and look at problem B. What do you think I need to do to figure out what my unit rate is? It says 1/4 of a gallon for every 3/10 of a mile. How would I find that answer to get the unit rate? That is correct. We are always going to take the first thing. So you can see that's the first thing in my original problem. So I've got 1/4 of a gallon per, or divided by, and then he just took the second part that we have of our original problem, 3/10 of a mile. All right, so when we do a problem like this, this means 1/4 divided by 3/10. Am I allowed to divide fractions?
No.
No, what method do I use? KFC. Brody, tell me what to write.
Keep the first.
Keep the first.
Change the sign.
Okay, change the sign.
And then swap the bottom.
All right, and flip that second fraction. When we do that, is there anything I can cross reduce?
Yes.
Nehemiah, what do I cross-reduce?
4 and 10.
The 4 and 10, what do they become?
A 2 and a 5.
A 2 and a 5. When you multiply that out, guys, what do you get? 5/6. Now listen, we just figured out what our numerator is here, okay? Because technically, we are dividing both the top and the bottom by 3/10. So this is 5/6 gallon per how much?
Every mile.
Per 1 mile, or for every mile. Because remember, when you're trying to find the unit rate, you are trying to get your denominator of 1. So we get 5/6 of a gallon per 1 mile. Number 4, every scientist estimates that a jet of liquid iron in the Earth's core travels 9 feet for every half an hour. How far does the liquid iron travel in 1 day? Does anyone think you understand what I need to do first? Shavaria, what's your guess?
You need to take 9 feet and put it over 1/2.
Okay, 9 feet. So if you were thinking about it, it would be like 9 feet per every half an hour. All right, so she decided not to use this little thing, but instead she showed it to us with the fraction bar, and she is dividing for every half an hour. Now notice, she gave us units attached. It's really important to always have your units attached. So now if I want to go ahead and figure this out, what does that mean I need to do?
You need to divide.
Divide 9 over 1 divided by half an hour. Cameron, what should I do next?
KFC.
All right, we're going to do KFC. Tell me what to do.
Keep the first.
Keep the first.
Change the division sign to a multiplication.
Change the sign.
And switch the numbers.
And flip the operation. When we do that, Madison, what is the answer? 18 what? Okay, 18 feet per, what'd you say the denominator was? Per hour. Now let's see if this makes sense. If I told you something was going to be 9 feet for a half an hour, does it make sense that it would then be 18 feet for a whole hour?
Yes, actually, yes.
Yeah, it does, because you're just doubling it, correct? Now, if I go back to my original question, this is what it says. How far does the liquid iron travel in 1 day? Did my answer come out as a day?
No.
No. Is there any kind of a conversion factor that we know in our head about hours per day? How many hours are in a day? 24. So guess what I need to do to turn this 1 hour into 24 hours? Multiply it by 24. If I multiply the denominator by 24, I have to also do what?
I said divide.
Multiply the numerator. Oh, yes, I meant to say, sorry. Multiply, okay? Go ahead and work that out. Remember, when we are practicing with a calculator in class, that means on your quiz that's on Monday, you get to use a calculator. Help me out to understand, guys. What's your answer?
432 feet.
432 feet
Over 24 hours.
per 24 hours. Now, guys, what is 24 hours equivalent to?
A day.
A day. So, since here it says, how far did the liquid iron travel in 1 day? Guess what I want my answer to say?
1 day.
432 feet per 1 day.
That's a lot of feet.
All right, section number 5. Tell whether the rates are equivalent. Guys, what does equivalent mean? Equal. If you look at this, 20 pounds per 2 years and 35 pounds per 3.5 years. Do those look equivalent? No, we can look at that and probably think, that doesn't make sense. But here's what you have to do. You have to turn both of them into a unit rate to figure out what the unit rate is and then compare them. Because right now I cannot compare 2 years and 3.5 years. So let's just do it like we normally would. We're going to start with the top one. 20 pounds per 2 years. How do I write that now as a ratio?
20 to 2.
Okay, 20 pounds, LBS is for pounds, per every 2 years. How would I write this second one, 35 pounds per 3.5 years, as a ratio, guys? 35 pounds per or over 3.5 years. Now, as I said, we are going to find the unit rate of both. In order to find that, what does the fraction bar right here mean? What operation?
Divide.
Divide. So I want you to figure out, guys, we should hopefully be able to do this in our head. What is 20 pounds per 2 years? 20 divided by 2 is 10. So 10 pounds per 1 year. Remember, the way that you have done that is you've divided by 2 on bottom, you've divided by 2 on top, and that helps us to understand it's 10 pounds per year. How would I do this one? 35 pounds for 3.5 years. I divide it. Remember, take your numerator first, 35, then divide by the second number, 3.5. Guys, when you do that, what do you get? 10 pounds per 1 year. Once again, all you've done is you divided by that denominator, divide by 3.5 on the top, also divide by 3.5 on the bottom. Guys, 10 pounds per year and 10 pounds per year, are those equivalent?
Yes.
Yes, they are. So while we thought at the beginning they were not equivalent, they actually are equivalent because their unit rate is exactly the same. Problem B. It says right here 7 miles per minute and 420 miles per 3 hours. Does anything look different or unusual about problem B than problem A? Janet, what's different about it?
Well, it's not telling us how many.
Very good. She says here we are comparing two things that have different units. While both of these say miles, what is the difference between these two? Minutes and hours. They're not the same. So in order to compare something, you have to put them in the same units. Whenever you're doing something like that, you will always convert the biggest one to the smallest one. So what's bigger, a minute or an hour? An hour. So now what I want you to do, we have to convert 3 hours into minutes. Guys, what conversion factor we know about minutes and hours?
60.
There's 60 minutes in 1 hour. So how many minutes are in 3 hours?
180.
So instead, we're going to put this as 180 minutes because 180 minutes means 3 hours. Now what I want you to do, since we've found that those two are the same units, I want you guys to try to do this with your partner and see if you can figure out if they are equivalent or not. All right, as I walked around, I saw a lot of excellent answers. The very first one, 7 miles per minute.
7 over 1.
You simply have 7 miles per 1 minute. You cannot reduce that anymore because we want a unit rate of 1, and the original problem gave us that. So that makes it a little bit easier. Now we go on to the next one. How do I write this as a fraction, guys?
420 over 100.
Once again, give me the units attached with it. 420
Miles
per.
180 minutes.
Okay, so whenever you do that, you're simply dividing. Guys, when you divide that, what do you get?
2.3 with a fraction bar over the 3.
2.3 repeating. Now, once again, you cannot give me this as your answer. I need units attached.
2.3 repeating miles.
Miles per
1 minute.
per 1 minute. Remember, if it helps you to understand, all you're doing is you're dividing the top by 180. You're also dividing the bottom by 180. That's how you get this to turn into 1 minute, okay? Now, guys, if I'm looking at this, 7 miles per minute, 2.3 miles per minute. Do those equal each other?
No.
No. So when it asks you, are they equivalent? The answer is no. Okay? In order to decide if they're equivalent or not, you always have to change that denominator into a 1 to find the unit rate of how much it is per 1 of something. So, ladies and gentlemen, tonight's homework is simply to work on these 7 problems for 5.2.